This video is going to be another one of those short explanation videos, and it's going to be the last topic that is going to be covered in Chapter 7. So our last integral application. And what it is it's using integration to figure out the distance that's been traveled, and it's often referred to as particle motion. The idea is you have something moving. It could be a car, it could be a person. I've even seen ones that say like a bug is moving along a axis or along a graph, but they just generically call it particle motion. So things are moving. We can use integrals to find how far they've moved. We can also use derivatives to tell us a lot of other things as well. Particle motion problems are really common on the AP test. You should be very comfortable with working with our basic functions of position, velocity, and acceleration, and knowing kind of how they all interact, and using those equations to help us figure out distance. So just some basic things that you should know from Calc 1. You should know that our position function, sometimes they use s of t, sometimes they use x of t. I feel like now they've been using x more and more, which is good because I don't like writing the letter s. It always looks like fives. You should know that if you take a position function and derive it, you get a velocity. Some of the easiest questions on the AP tests are ones where they give you a position function and ask for the velocity after 3 seconds. So you're taking the derivative, plugging 3 in, getting your velocity. If you derive it again a second time, if you derive velocity, you get acceleration. So those are our derivative kind of applications. We can also work in reverse. So if I integrate acceleration, I get velocity, and if I integrate velocity, I get position. A lot of times with these, we have to use initial condition. Like if we know our starting velocity or our starting position, this is what allows us to find our C value. So those would have been things that we did back in Chapter 2 for the derivatives and Chapter 4 for the integrals. When we talk about units, the AP is not big on unit conversion, anything like that. But keep in mind that your position, so your x of t, is just a location, or it could be something like where it's a certain meter mark. So your position could be at the 3-meter mark or the 3-mile mark. Your velocity is going to be written something like meters per second, miles per hour, feet per second. Acceleration is going to be meters per second, or feet per second. So you're going to have something like meters per second squared, or it could be miles per hour squared. You always have that unit of time being squared. And I only mention that because sometimes you can get some really cheap points on the AP test if you just put the correct unit at the end of a velocity or acceleration problem. So first, I want to make sure you understand the sign of the velocity. So we know velocity, it has a sign, it's positive or negative, and I want to make sure you know what that means. So I'm going to use this example to kind of take you through some basic types of questions that can be asked that you would have been hopefully comfortable doing last year. So I'm giving you a position function, t to the fourth minus 18t squared plus minus 49. I'm reminding you that time can't be negative. So you'll see that in a lot of problems where it'll say t is greater than or equal to 0, just reminding you we're not going back in time. So we're going to write a velocity equation. So our velocity is 4t cubed minus 36t, and then that's it, because the derivative of negative 49 is 0. We can factor this velocity. This one is one to be done without a calculator. It factors 4t out, and then you get t squared minus 9. So you get 0 and plus or minus 3. However, you can't have a negative time, so we're just going to look at 0 and 3. The purpose or the importance of knowing t equals 0 and t equals 3, or when the velocity is 0, is if the question asks you when the particle or the object is at rest. If something is at rest when it has a 0 velocity. So essentially what you're doing here when you're setting in this equal to 0 is you're finding those times where it is at rest. The other thing you're doing is you're also checking to see when are the times that it could be switching directions. Because here's what velocity tells us in the sign. If we have a positive velocity, what that means is it's moving to the right. I know in physics sometimes you'll say like the positive direction. They actually prefer on the AP test that you use words like right and left, up and down. So if it's moving horizontally with a positive velocity, it's moving to the right. If it's moving vertically, every now and then you'll have one like that. You would say that up is the positive direction. If you have a negative velocity, then we say our particle is moving to the right. Or if it's running up and down, it would be moving down. You want to use directional words. That is something that I've heard in different AP conferences I've been to. So we can make a little sign chart here. Say we're starting at time of 0, and we know something's happening at a time of 3. If I look at the sign of my velocity, So if I pick a test point between 0 and 3, this is going to look familiar like when we did increasing and decreasing. If I pick like 1 for t, if I put a 1 in for my velocity equation, I get a positive times a negative. That tells me it has a negative velocity between 0 and 3, which tells me that that is the time where my particle is moving to the left. After 3, if I put a number like 4 or 5 into my velocity equation, I'm going to get everything positive, which tells me since it has a positive velocity, it is moving to the right. I have seen AP questions that simply want to know, when does the particle change direction and why do you know that? And you would say, and for this one, well, I know the particle will change directions at 3 because that's when the velocity went from negative, which means it's moving to the left, to positive, which means it's moving to the right. You will also have questions that may say something like, at a particular time, which direction is it moving? And you can take that time and plug it into velocity and look for positive, meaning moving to the right, or negative, moving to the left. Acceleration then would be the next derivative. I'm not going to do a ton with acceleration right now, but I do want to remind you how to find it. So I'm going to derive again. So I get 12t squared minus 36. You can use that to do a couple things. You can use that to figure out when acceleration is 0. You could set that equal to 0 and factor it. You could also just use it to answer basic questions like, what's the acceleration after 2 seconds, or what's the acceleration after 10 seconds? Usually the acceleration questions are pretty simplistic, more that they're just checking that you know how to find the equation and plug numbers in. So getting to our goal here of finding distance traveled. If we have a velocity function, we have a velocity equation, and we integrate from A to B, that will give us what's called the net distance traveled. So if you just take any velocity equation and you go from time equals 1 to time equals 10, again, those can be your boundaries, and you put it in your calculator or you do it by hand, your answer will represent your net distance traveled. Now, keep in mind, there's a difference between net distance and total distance, which is something I want to talk about. Net distance is how far away you are from where you started. It's basically displacement in a physics class. So, for example, let's say I start at the origin. So I'm starting at my number line. I start at 0. If I walk 3 units to the right, and then I walk 6 units to the left, and then I turn around and walk 1 unit to the right, my net distance traveled, well, I went 3 right, 6 left, 1 right. I end up at -2, which means I traveled 2 units. That's my net distance traveled. That's often not what they want on the AP test. What they're looking for on the AP test is what's called total distance. Total distance is actually how far did you actually go, including all your backtracking. So if I'm this like particle that's moving and I go 3 units to the right and then 6 units to the left and then 1 unit to the right, I went 10 units. I didn't end up 10 units away from where I started, but I actually walked or traveled 10 units. That's total distance. So your total distance in this case would be your 10 units, whereas your net distance would be only 2 units. So the important thing to understand is if you're asked for total distance traveled, if you strictly just integrate your velocity, you won't necessarily get that total distance. That's only going to be true if you have no direction change. So if I just start moving to the right and I never stop moving to the right in that interval, I integrate, I get a total distance. But often they're not going to make it that simple on you. What they're going to do on the AP test is they're going to purposely pick questions that do have a direction change and force you to look into that direction change and find the distance. For example, the one we just did, if you integrated this velocity function and you went from 0 to 5, because I changed directions at 3 seconds, my answer would only indicate how far away I was from where I started. I would have to break it up and look at what happens when I'm going to the left, how far do I go, and what happens when I'm moving to the right. So I have to kind of break it as like multiple different integrals. Another kind of determination, a lot of times you'll see questions that will ask about velocity and then they may ask about speed. The only difference between velocity and speed does not have a sign. So if you look about speed is the absolute value of velocity. So if you're doing a problem and it wants to know what is the speed after so many seconds, essentially it's saying, I don't care what the sign is, I don't care if it's positive or negative, I just want that absolute value or that numeric value. So when we're doing total distance, there's a couple ways to go about doing it. And we're going to practice it a lot when we're together in class. This is just kind of giving you some background. If you're allowed to use a calculator, you can actually use absolute value bars. And when you integrate, if you integrate the absolute value of velocity, it will give you the total distance. However, not all problems are calculator related, so I want to make sure you're comfortable if you can't use a calculator. If you can't use a calculator, you're going to have to establish if there's a direction change in your interval, and you're going to have to treat each individual integral separately. So you're going to have to go through and say, well, I know it changes directions at 3, so let's look at the distance I traveled before 3, and then let's look at the distance I traveled after 3. Last little explanation piece, and then I promise when we're together again, we'll go through all of this kind of a second round through and hoping makes more sense when you hear it a second time. When you talk about whether or not a particle or an object is speeding up or slowing down. Speeding up or slowing down, there's a lot of ways to talk about it in physics, but I'm going to keep it real simple for calculus. If my velocity and my acceleration have the same sign, so if they're both negative or both positive, we say that it's speeding up. So if I can find a time where I have a positive velocity and a positive acceleration, or a negative velocity and a negative acceleration, we would say that that particle at that moment is speeding up. If my velocity and my acceleration have opposite signs, so one's positive, one's negative, we say that that particle is slowing down. Think of the idea as they're kind of working against each other, pushing against each other, and you will have a particle that slows down. So if you know that at time 3, you have a positive velocity and a negative acceleration, or the other way around, a negative velocity and a positive acceleration, then we know that that particle is slowing down. So that is just a quick overview of what we're going to do. We'll get in and we'll do a bunch of problems together. I am going to have you do a short set of problems that just kind of review particle motion, but we'll get more into the distance traveled when we are together.